LLaVA-Interactive, an all-in-one demo for image chat, segmentation, generation and editing. LLaVA-Interactive is a research prototype for multimodal human-AI interaction. The system can have multi-turn dialogues with human users by taking multimodal user inputs and generating multimodal responses. Importantly, LLaVA-Interactive goes beyond language prompt, where visual prompt is enabled to align human intents in the interaction. The development of LLaVA-Interactive is extremely cost-efficient, as the system combines 3 multimodal skills of pre-built AI models without additional model training: visual chat of LLaVA, image segmentation from SEAM, as well as image generation and editing from Glygen. A diverse set of application scenarios is presented to demonstrate the promises of LLaVA-Interactive and to inspire future research in multimodal interactive systems. Distil-Whisper, robust knowledge distillation via large-scale pseudo-labeling. As the size of pre-trained speech recognition models increases, running these large models in low-latency or resource-constrained environments becomes challenging. In this work, we leverage pseudo-labeling to assemble a large-scale open-source dataset, which we use to distill the Whisper model into a smaller variant called Distil-Whisper. Using a simple word error rate (WER) heuristic, we select only the highest quality pseudo-labels for training. The distilled model is 5.8 times faster, with 51% fewer parameters, while performing to within 1% WER on out-of-distribution test data in a zero-shot transfer setting. Distil-Whisper maintains the robustness of the Whisper model to difficult acoustic conditions, while being less prone to hallucination errors on long-form audio. Distil-Whisper is designed to be paired with Whisper for speculative decoding, yielding a 2x speed-up while mathematically ensuring the same outputs as the original model. To facilitate further research in this domain, we make our training code, inference code, and models publicly accessible. Controllable music production with diffusion models and guidance gradients. We demonstrate how conditional generation from diffusion models can be used to tackle a variety of realistic tasks in the production of music in 44. 1 kHz stereo audio with sampling time guidance. The scenarios we consider include continuation, in-painting and regeneration of musical audio, the creation of smooth transitions between 2 different music tracks, and the transfer of desired stylistic characteristics to existing audio clips. We achieve this by applying guidance at sampling time in a simple framework that supports both reconstruction and classification losses, or any combination of the two. This approach ensures that generated audio can match its surrounding context, or conform to a class distribution or latent representation specified relative to any suitable pre-trained classifier or embedding model. The generative AI paradox. What it can create, it may not understand. The recent wave of generative AI has sparked unprecedented global attention, with both excitement and concern over potentially superhuman levels of artificial intelligence. Models now take only seconds to produce outputs that would challenge or exceed the capabilities even of expert humans. At the same time, models still show basic errors in understanding that would not be expected even in non-expert humans. This presents us with an apparent paradox. How do we reconcile seemingly superhuman capabilities with the persistence of errors that few humans would make? In this work, we posit that this tension reflects a divergence in the configuration of intelligence in today's generative models relative to intelligence in humans. Specifically, we propose and test the generative AI paradox hypothesis. Generative models, having been trained directly to reproduce expert-like outputs, acquire generative capabilities that are not contingent upon, and can therefore exceed, their ability to understand those same types of outputs. This contrasts with humans, for whom basic understanding almost always precedes the ability to generate expert-level outputs. We test this hypothesis through controlled experiments, analyzing generation versus understanding in generative models across both language and image modalities. Our results show that although models can outperform humans in generation, they consistently fall short of human capabilities in measures of understanding. as well as weaker correlation between generation and understanding performance, and more brittleness to adversarial inputs. Our findings support the hypothesis that models' generative capability may not be contingent upon understanding capability, and call for caution in interpreting artificial intelligence by analogy to human intelligence. AMSP, superscaling LLM training via advanced model states partitioning. Large language models, LLMs, have demonstrated impressive performance across various downstream tasks. When training these models, there is a growing inclination to process more tokens on larger training scales, but with relatively smaller model sizes. Zero redundancy optimizer, Zero, although effective in conventional training environments, grapples with scaling challenges when confronted with this emerging paradigm. To this end, we propose a novel LLM training framework, AMSP, which undertakes a granular partitioning of model states, encompassing parameters, P, gradient, G, and optimizer states, OS. Specifically, AMSP-1 builds a unified partitioning space, enabling independent partitioning strategies for P, G, and OS. 2. Incorporates a scale-aware partitioner to autonomously search for optimal partitioning strategies. 3. Designs a dedicated communication optimizer to ensure proficient management of data placement discrepancies arising from diverse partitioning strategies. Our evaluations show that AMSP achieves up to 90.3% scaling efficiency across 1024 GPUs. De-Diffusion makes text a strong cross-modal interface. We demonstrate text as a strong cross-modal interface. Rather than relying on deep embeddings to connect image and language as the interface representation, our approach represents an image as text, from which we enjoy the interpretability and flexibility inherent to natural language. We employ an autoencoder that uses a pre-trained text-to-image diffusion model for decoding. The encoder is trained to transform an input image into text, which is then fed into the fixed text-to-image diffusion decoder to reconstruct the original input, a process we term De-Diffusion. Experiments validate both the precision and comprehensiveness of De-Diffusion text, representing images, such that it can be readily ingested by off-the-shelf text-to-image tools and LLMs for diverse multimodal tasks. For example, a single De-Diffusion model can generalize to provide transferable prompts for different text-to-image tools, and also achieves a new state-of-the-art on open-ended vision language tasks by simply prompting large language models with few-shot examples. ChipNeMo, domain-adapted LLMs for chip design. ChipNeMo aims to explore the applications of large language models, LLMs, for industrial chip design. Instead of directly deploying off-the-shelf commercial or open-source LLMs, we instead adopt the following domain adaptation techniques: custom tokenizers, domain-adaptive continued pre-training, supervised fine-tuning, SFT, with domain-specific instructions, and domain-adapted retrieval models. We evaluate these methods on 3 selected LLM applications for chip design: an engineering assistant chatbot, EDA script generation, and bug summarization and analysis. Our results show that these domain adaptation techniques enable significant LLM performance improvements over general-purpose base models across the 3 evaluated applications, enabling up to 5 times model size reduction with similar or better performance on a range of design tasks. Our findings also indicate that there's still room for improvement between our current results and ideal outcomes. We believe that further investigation of domain-adapted LLM approaches will help close this gap in the future. Grounding visual illusions in language. Do vision language models perceive illusions like humans? Vision language models, VLMs, are trained on vast amounts of data captured by humans, emulating our understanding of the world. However known as visual illusions, humans' perception of reality isn't always faithful to the physical world. This raises a key question. Do VLMs have the similar kind of illusions as humans do, or do they faithfully learn to represent reality? To investigate this question, we build a dataset containing 5 types of visual illusions and formulate 4 tasks to examine visual illusions in state-of-the-art VLMs. Our findings have shown that although the overall alignment is low, larger models are closer to human perception and more susceptible to visual illusions. Our dataset and initial findings will promote a better understanding of visual illusions in humans and machines, and provide a stepping stone for future computational models that can better align humans and machines in perceiving and communicating about the shared visual world. The code and data are available at project's website. ChatCoder. Chat-based refine requirement improves LLMs code generation. Large language models have shown good performances in generating code to meet human requirements. However, human requirements expressed in natural languages can be vague, incomplete, and ambiguous, leading large language models to misunderstand human requirements and make mistakes. Worse, it is difficult for a human user to refine the requirement. To help human users refine their requirements and improve large language models' code generation performances, we propose ChatCoder, a method to refine the requirements via chatting with large language models. We design a chat scheme in which the large language models will guide the human users to refine their expression of requirements to be more precise, unambiguous, and complete than before. Experiments show that ChatCoder has improved existing large language models' performance by a large margin. Besides, ChatCoder has the advantage over refine-based methods and LLMs fine-tuned via human response. Text rendering strategies for pixel language models. Pixel-based language models process text rendered as images, which allows them to handle any script, making them a promising approach to open vocabulary language modeling. However, recent approaches use text renderers that produce a large set of almost equivalent input patches, which may prove suboptimal for downstream tasks due to redundancy in the input representations. In this paper, we investigate 4 approaches to rendering text in the pixel model, Rust et al., 2023, and find that simple character bigram rendering brings improved performance on sentence-level tasks without compromising performance on token-level or multilingual tasks. This new rendering strategy also makes it possible to train a more compact model with only 22M parameters that performs on par with the original 86M parameter model. Our analyses showed that character bigram rendering leads to a consistently better model, but with an anisotropic patch embedding space, driven by a patch frequency bias, highlighting the connections between image patch and tokenization-based language models.